In this video, we're going to talk about how to download data from the UK for GDP and population, calculate GDP per capita going all the way back to 1700, calculate the compound annual growth rates for the 1700s, the 1800s, and then 1900 to 2016, graph the data, and project the data another 300 years to see what GDP per capita would be like based on different growth rates. So in order to start out, we're going to go to Fred and put in the GDP for the UK that goes back all the way to 1700. And just keep in mind that whenever data goes back, into the 19th century and beyond, take it with a grain of salt. It's obviously, taken a lot of hard work by economic historians to put this together, but we didn't have the same type of surveys back then and measuring tools. So here's GDP. We want GDP per capita, so what we are going to do is we're going to add population. So we're going to add POP-UKA. And this is obviously from the same data source because it goes back to 1700 as well. And we don't need to worry too much about this graph. We could make it prettier if we wanted to. We could actually calculate real GDP per capita in Fred if we wanted to, but we're going to do it in Excel. So we're going to download this data. And we will save it here. We'll just call it UK Growth 2 since I've already done this. All right, and then we're going to open it up in Excel. I'm going to bring Excel over to this screen. All right. Now, so we're going to enable editing. And the only thing to note is that our real GDP numbers are in millions of pounds. It is chained 2013 pounds, so they're already adjusted for inflation, so we don't need to worry about that. Our population is in thousands, so when we calculate our real GDP per capita, we need to adjust one of our numbers so that we get actual pounds rather than something in thousands or millions. So we can just do equals 1,000 times real GDP. That will put that in thousands as well. And then divide by population, which is already in thousands. And then put this in pounds. All right, and we don't really need the pence, right? Okay, then we just copy it down, right, all the way. So that's going to give us GDP per capita all the way to 2016, so 1700 to 2016, 316 years of data. That's about as good as we can get in macroeconomics. So the first thing we want to do is just graph it. So we select that data. We do insert line graph, and we're going to move it over. We'll move our chart over to a new sheet. And you can see our horizontal axis is not labeled correctly yet because we haven't told it the years. So we have to go to select data. Edit the horizontal entries. We go back here, and then we can highlight all of that data. And then there we go. So we have 1700 all the way to 2016. And you can see the financial crisis there in 2008, 2009, right? And it took us a while to get back. And of course, if this data went to 2021, we would see the effects of the pandemic as well. So the next thing we want to do is to calculate the growth, the average annual growth. So we're going to do that for the 1700s, the 1800s, and then 1900 to 2016. And the best way to do that, I think, we could do it all at once, but I think it might be easier to do it in a few steps. So we'll have starting real GDP per capita, ending real GDP per capita, and then the compound annual growth rate. So the CAGR, or compound annual growth rate, is the average growth rate as if we went smoothly from our starting number to our ending number. And what it does is it really shows the power of compound annual growth. So our starting number for the 1700s is just this value here, real GDP per capita in 1700. Our ending number is going to be the value in 1800, so we'll go down here. And I'm just going to show you how to do this one, and I'll leave the others for yourself as an exercise. For the 1800s, starting real GDP per capita would be the value in 1800, ending would be 1900, and then here, this would be 1900 and 2016. So the formula for the compound annual growth rate is fairly straightforward. It's just equals. We always have to start with an equal sign when we're doing Excel. And the ending value divided by the beginning value, close our parentheses, and then we raise it to the 1 divided by however many years we are growing. So for the 1700s and 1800s, that will be 100 years. For the 1900 to 2016, that will be 116 years. And then we have to subtract 1 in order to put it into percentage terms. So we can put that into percent, give us a couple decimal places, and you can see that while there was positive growth in the 1700s, it was very low. And what you'll see is that it was faster in the 1800s and then faster in the 1900s and 2016. So what I am asking my class to do is to project growth out to 2316, so 300 years after the data ends, assuming that growth is the same as the number we get for the 1900 to 2016. So let's see how to do that. So we'll say real GDP per capita 2316. And we'll do it for a bunch of different growth rates. So we'll say, all right, well, what if it's 0.5%? What if it is 1%? What if it's 1.5%? And what if it's 2%? And of course, in what I'm asking my class to do is to use the compound annual growth rate for the 1900s to 2016. So first we need to know what we're starting with, right? And so what we're starting with is the value of real GDP per capita in 2016. So we can just go down here and put that value in. And then calculating out to 2316, so 300 years in the future, is just going to be our starting value times 1 plus the growth rate. So that's 0.5% here. And then raised to however many years we're doing. So we're doing 300 years here. So 300. And so, I made a mistake. What did I do? Equals, I don't know why it said 118. That should be G18 there. There we go. Oh, I know what I did. I didn't do the times correctly. That's what it is. So it's G18 times 1 plus F19 to the 300 power. So you can see, even if we only grow at 0.5% per year, so just a little bit faster than we did in the 1700s, in 300 years, GDP per capita, so average GDP per person, would be 127,019 pounds in the UK. And then we can just drag this, well, we can't quite drag it down because we need to make sure that we're not moving this. So we can hit F4, or if you're using a Mac, Command T, to make sure that's an absolute reference there. The other reference we have is the growth rate. We want that to change. So now we can just drag it down. And you can see that if we grow at 1%, it would be 562,000 pounds, almost 563,000. And if we grow at 1.5%, it's almost 2.5 million pounds per person. And if we grow at 2%, it's over 11 million pounds. And so, you know, as a Star Trek fan, as a fan of science fiction, I always like to think, well, you know, economic output would have to be fantastic to be able to produce that kind of technology, those kinds of ships. But if GDP per capita is, you know, somewhere between 2.5 and 11 million pounds per person, then maybe we could actually do that. So that's all for now, and I will see you in the next video.